motion, moving so free, bonds forming, creating chemistry.
Collision theory is a fundamental concept in chemistry that explains how and why chemical reactions occur. It is a theory for understanding the factors that influence the rate of a chemical reaction. In this video, we will explore collision theory and the various factors that affect the rate of chemical reactions. Collision theory states three key components for a chemical reaction to occur. 1. The reacting molecules must collide with each other. 2. With sufficient activation energy. And 3. In the proper orientation. So, in order for a reaction to occur, particles must collide at the correct orientation with sufficient kinetic energy. The molecules must collide in the correct orientation for the reaction to occur and form the right products. They must have enough kinetic energy to be able to break the bonds in the reactants and form new bonds to create the products. The more often the reactant molecules collide, the more likely a reaction will occur. Activation energy. To grasp the concept of collision theory, you have to know about activation energy. Simply put, activation energy is the minimum amount of energy particles must have for an effective collision. Factors affecting reaction rates. Several factors can influence the rate of a chemical reaction by affecting the collision frequency, collision energy, or collision orientation. These factors include the nature of the reactants, temperature, concentration for aqueous solutions, pressure for gases, surface area, and the presence of a catalyst. Temperature. Increasing the temperature of the reaction increases the average kinetic energy of the reactant molecules, leading to more frequent and more energetic collisions. This results in a higher reaction rate. Think of it like this: if there's a fire around you, you'll probably start moving faster to get away from it. And if everyone does the same thing, you're probably going to bump into each other, right? It's the same concept with temperature in collision theory. Concentration for aqueous solutions. Increasing the concentration of the reactants increases the number of molecules available for collisions, leading to a higher reaction rate. Imagine you have a room with only 2 or 3 people who are all running around. You probably won't bump into each other a lot. Now imagine there are more than 30 people. You're probably going to bump into each other a lot more. It's the same with concentration. There's a higher collision frequency when more molecules are available for collisions, which increases the reaction rate. Pressure for gases. The effect of pressure is almost the same as that of concentration, except pressure only applies to gaseous reactions. Higher pressure means more molecules are present in the same volume, leading to a higher frequency of collisions between reactant molecules. Increasing the pressure of a reaction with gases increases the concentration of the reactant molecules, leading to more frequent collisions and a higher reaction rate. Surface area. When you increase the surface area of a reactant, more particles are exposed to the other reactant, so it increases the number of available collision sites, which creates a greater chance of particles colliding. Altogether, this leads to a higher rate of reaction. You can increase surface area by breaking the solid into smaller pieces or grinding it into a powder. A catalyst is a substance that increases the rate of a chemical reaction without being consumed itself. Catalysts provide an alternative pathway with a lower activation energy, causing a faster reaction. Essentially, a catalyst just lowers the activation energy. We also observe catalysts all the time in our daily lives, but to simplify it, let's replace a reaction with an activity. If you're going on a run and a goose starts chasing you, that would make you run faster. The fierce goose chasing you is the catalyst in this reaction. The goose isn't part of the activity, but it causes you to speed up without changing in the process. In this video, we explored the concept of collision theory and the various factors that can affect the rate of a chemical reaction. By understanding these principles, we can better predict and control the rates of chemical reactions, which are crucial in many scientific and industrial applications. Thanks for watching.